Hello guys, this week we're going to be discussing percent of change and percent error. Now, the whole unit we've talked about percents and we've talked about the percent proportion and how you can set it up with the part over the whole is equal to the percent over 100, and you can solve for percent, or you can solve for one of the parts of the percent proportion. And in today's lesson, we're actually going to be talking about the change in a percent. That means, like, let's say if you were going to Black Friday shop and you noticed that an iPhone was $150 and it increased to $175, and so you wanted to know how much that phone, the percent of that phone went up, it increased. Or let's say you were going, to a sale and you noticed an item at JCPenney had been $35 and now it is $20, and you wanted to see what the percent decrease was on that particular item. So that's what we are using. It's called the percent of change, and we're looking for the percent of increase or the percent of decrease. And that, knowing that, is you're going to have to use a little common sense. If the price was higher originally and it gets lower, then that is a percent decrease. And if it was lower originally and it gets higher, then that means it's a percent increase. Okay, so we're going to start with this first problem. It's our first example. And it says, Ashley earned $20 babysitting in January. In February, she earned $32. What is the percent change in her earnings? Okay, so let's go back. It says she earned $20 in January, okay? And in February, which comes after January, she earned $32, okay? All right, so we know that this is the original amount that she earned, and this is the new amount, okay? That is going to be a percent increase because she was earning $20, now she's earning $32, and 32 is greater than 20. Okay, so the step one says find the difference, and difference means to subtract. So we're just going to write 32 minus 20. And we are going to subtract those two. So that is 12. All right, so down here it says step 2. It says set up the following ratio, which is just setting up the fraction of the difference, which is 12. That's the difference in the two amounts, over the starting amount. And the starting amount is not 32. The starting amount, the original amount, is 20. So remember, you have to go back up to the problem and look for what the original was. And I had circled it and put an O over the top of it for original. And the second amount, the N, stood for new. Okay, so we have the difference over the starting amount. Now, the step 3 says change to a percent. So I'm going to tell you there are two different ways we can do this. Now, the first way is to just take 12 over 20. Now, if you take your calculator, you're going to divide 12 by 20. So 12, because that's a fraction, 12 divided by 20, and so top divided by bottom gives you 0.6, which is actually 6/10, okay? Now, you have to change that 6/10 into a percent. And the way you do that is you move your decimal 2 places to the right. And that gives you 60%. Okay? That is the first way we do it. The second way we do it looks very familiar because we will use the percent proportion, which is what we've used this last part of our unit. We would actually just set up we would use our 12 over our 20 as our part over our whole. And we would put the 100 on the bottom of this because we're looking for the percent of change. And so then we would just multiply 12 times 100. That gives us 1200. And we would multiply 20 times x, which gives us 20x. divide by 20 on both sides. And if you take your calculator and you say 1200 divided by 20, you get 60. 60 hundredths, 60 over 100, is the same thing as 60%, which is also the same thing as your 6/10. So either way you want to do step 3 is completely fine. You find the difference. You are going to take the difference over your starting amount or your original amount, and you either divide them to get the decimal and turn that decimal into a percent, or you set it up x is equal to x over 100 and do cross products and get your percent that way. Either way you want to do it. Okay, our second example here is an example of percent error. Now, it's almost the same thing as percent of change or percent increase, percent decrease, but it is the error. So in other words, let's say, if scientists use percent error quite a bit, if they have a educated guess, a hypothesis that something's going to be, let's say, a certain degrees Celsius, and it actually turns out to be just a few degrees colder, they might want to calculate the percent error of where they were off at. So, and that is one way you could use percent error. Let's see. Let's look at the example. It says the predicted temperature today, so this would be like a forecast. So in other words, your meteorologist used percent error as well. So the predicted temperature today was a high of 55 degrees Fahrenheit. The actual high temperature was 47 degrees Fahrenheit. Calculate the percent error. Okay. Let's look at, the predicted temperature is 55 degrees. The actual temperature was 47. So let's see, predicted would be what they thought it was going to be. So it says find the difference. So we're going to put 55 minus 47. And 55 minus 47 is going to be 8. So they're 8 degrees off. So now step 2 is a lot like the step 2 in the percent change, but instead of using the difference over the original, it's the difference in the two numbers, which is 8, over the actual value. So the actual high temperature is 47 degrees, okay? So that is the difference in the two formulas. Is that you have to make sure that you are looking for the bottom value, the denominator. So now we're going to do it both ways. Again, we have our fraction. We have 8 over 47. So if we take 8 divided by 47, we get a decimal, and I'm going to round it to the nearest hundredths place. So my decimal is 0.17, and it goes on 0.21277, but I just rounded to the hundredths place. And so if I'm to move my decimal 2 places to the left, which is like multiplying by 100, I would get 17%. Now I'm going to do it the other way. For those of you that like the percent proportion better, I'm just going to put an equal sign, and I'm going to set it equal to 100. X. So 100 times 8 is 800. I write it up here. Okay, and x times 47 is 47x. I'm going to divide by 47 on both sides. Take my calculator. 800 divided by 47 gives me 17.02, which is rounded to 17%. So there you go. Either way, you have 17%. Okay? So those are the two examples. Now we're going to do some problems together, and I'll stop the video a time or two and have you guys answer the questions. So let me get to the next page. Okay, so we are on some practice problems now, and I will tell you that the percent error problems and the percent of change problems are mixed up, so we have to know what we're looking for, and we will use our cubes method to find that out. So let's read the first question. It says, in her last basketball game, Chloe scored 8 points. Today, she had a personal best and scored 15 points. Calculate the percent change. Okay, so that means that we are going to say her last basketball game was the original game. That was the first game because she played it first. So this is the original. So I'm going to make my pen red. This is the original. I'm going to put an O there. And 15 is going to be the new, because that's the one she did the most recent. So that's the newest, okay? The original is going to be the oldest one. All right, so remember, we're going to take the difference. So we're going to say 15 minus 8. And 15 minus 8 equals 7, okay? So that is our difference. So now we're going to say our difference divided by our original, and our original was 8. Okay, now that's a 7 if you guys can't tell. 7 divided by 8, if you take your calculator, 7 divided by 8 is going to be 875 thousandths. So that equals 0.875. If you turn that into a decimal, you're going to move your decimal 2 places to the right. And you're going to say 887.5%. Or you can say 8 over 7 is equal to x over 100. 7 times 100 is 700, and 8 times x is 8x. So 700 is equal to 8x. Divide by 8 on both sides, and you get, see, in calculator, 87.5. So you get the same thing no matter which way you do it. Okay. Aaron's cat Ginger likes to eat. The vegetarian was concerned about Ginger's weight and put the cat on a strict diet. Over a 6-month period, Ginger's weight decreased from 22 pounds to 16.5 pounds. Calculate the percent of change, okay? Let's go back here. Now, I did not address in question number 1, was this a percent increase or a percent decrease? Okay, so it's actually going to be a percent increase because the new score is bigger than the old score. All right, so let's look back at number 2 again. I apologize for that. It says calculate the percent of change. So I want you to answer the question. Is this percent of change going to be an increase or a decrease? Okay, hopefully you guys got the question right because it says decreased right here. Right there. So it did decrease. So let's say we've got the 22 is our original and 16.5 is our new weight. Okay. So we're going to take the difference. We're going to say 22 minus 16.5. And we're going to use our calculator. So 22 minus 16.5 is 5.5. 5.5 pounds, okay? Now, that is our difference, so we're going to take our difference, 5.5, and we're going to put it over the original, and the original was 22 this time because it was a decrease, so it's the larger amount. And when you do that, you are going to divide 5.5 divided by 22, and you get 0.25. Okay, so if you have 25 hundredths, what is the percent? The percent is 25%. So you're going to move your decimal 2 places to the right and get 25%. I'm not going to do the percent proportion with you guys this time, but if you like doing that method, you can do that. I'm going to go ahead and just divide and then move my decimal. But like I said, you are more than welcome to do it either way. You recently started wearing a device to track how many steps you take in a day. You estimated that you would take 7,500 steps in a day. You actually took 2,000 or 12,500 steps. Calculate the percent error. Okay. So if we look at this, we say that you estimated that it would be 7,500 steps, but you actually took 12,500. Okay. So we start off with the difference. We say 12,500 minus 7,500. Use your calculator. 12,500 minus 7,500 is 5,000. So you have a difference of 5,000 steps. Okay. Now we're going to look at how you set it up. It's a percent error, so it's not the original amount. What are we going to look at as the denominator? It's not the original amount. What is it? I hope you said the actual amount, because that's what it is. It is for percent error, it is the difference over the actual amount. So 5,000 is the difference over the actual is 12,500. Okay, so if we take 5,000 divided by 12,500, what did you get? I got 4/10. And 4/10 is a decimal. Moves over 2 places, and that is 40%. That is a percent error of 40%. Okay, Liam's last grocery bill was $105. This week his bill was $85. Calculate the percent change, round to the nearest hundredth. Okay, so we're talking about money, so we always round to the nearest hundredth. So let's look. If his bill last week was $105 and his bill this week was $85, then his bill decreased, right? So it's going to be a percent decrease. This was the original amount, and this is the new amount. Okay, so remember, whatever, if the original amount is higher than the new amount, it's a decrease. If the original amount is lower than the new amount, it's an increase. All right, find the difference. So let's do $105 minus $85. Put that into the calculator. 105 minus 85, we get 20. $20 difference. Okay, so now we're going to put $20 over what was our original amount. 105 was the original amount. So now we're going to, like I said, at this point you can set it up and say equals 100x over 100, or you can just divide it. Either way you want to do it. So I am going to say 20 divided by 105. That gets me the decimal of 0.19047619. And I'm going to just round to the nearest hundredth, so it's 190. So that 0 actually just drops off. So it's just 119, right? 19 hundredths. And if I move my decimal 2 places to the right, I'm going to get 19%. Okay, and it's a 19% decrease. I don't think I did that for number 2. Number 2's was also a, let's see, a decrease. Put that on there. Okay, 19% decrease. Number 1's was an increase. Because that is part of the question too. It goes up or down on the percent of change. All right. Here's 4 more questions for us. It says, last year you received 25 Valentine cards from all of your friends. This year you received 30 total Valentines. Calculate the percent change, okay? So if we had 25 originally and 30 for our new, well, 25 is smaller than 30, so we're going to have a percent increase. I'm just going to put an increase arrow up there so I don't forget to mark the increase this time, okay? All right, so our difference is 30 minus 25, and that's going to be 5, okay? So 5 is our difference, so we put 5 over, and let's go back up here. Our original was 25, so we're going to put 25, because remember, for percent change, it is the original, or the difference over the original. Percent error is the difference over the actual, okay? All right, so this one I think I'm going to just go ahead and do x over 100 just because I want to just do it once. So if I was to do that, I would say 5 times 100 is 500, and 25 times x is 25x. And I'm going to divide by 25 because x times something, x times 25 equals 500. So let's see what 500 divided by 25 is. It is 20. So x equals 20%, and it's a 20% increase. Okay. You bought your friends a heart-shaped pound of chocolate caramels. You anticipated each chocolate was 50 calories. Each chocolate caramel is actually 67 calories. Calculate the percent error. Okay, so this is, we have the 50 calories was what the anticipated was. The actual amount was 67. So remember, the percent error equation is going to be your difference over your actual. Okay, so let's look at the difference here is 67 minus 50, and that equals 17. Okay, now we're going to do 17 over, which one are we supposed to put the 17 over, the 67 or the 50? I hope that you guys said 67 because that's the actual amount, okay? So on this one, I'm going to do my division, 17 divided by 60. That gives me 0.283 repeating. Okay, so if I make that decimal into a percent by moving my decimal over, that was supposed to be moved over, it's going to equal 28.3 repeating percent. Or you could just write 28%. Alrighty, let's look at number 7. Candy hearts cost $3.50 for 1 pound bag. Today was your lucky day and they were on sale for $2.75. What was the percent of change? Okay, percent change means it's going to go up or down. So if our original cost was $3.50 and our new cost is $2.75, it is a percent decrease, right? So I'm going to put an arrow going down, percent decrease. So I don't forget. I seem to forget that. Okay, so let's take the difference. We're going to say $3.50 minus $2.75. Put that into your calculator. $3.50 minus $2.75, and that gives you 75 cents. Okay, Now we're going to take the 75 cents, which is the difference. And we are talking about percent change. It's the difference over the original. Okay? And the original is back up here. It's $3.50. So if I were to find my decimal, what is my decimal version of 75 cents over $3.50? I hope you said 0.214, and you kept on going, okay? 21428.571, but we're going to stop and we look, and that 4 is basically going to drop off, and we're going to just keep it 21. So I'm going to move that decimal over, and it's going to be 21 or 21.4%, however you want to write it. Okay, last question. You purchased 20 Valentine cupcakes for a party, but only 15 kids attended. Calculate the percent error, okay? So this question, 20 is the estimated, okay? And 15 is the actual, because that's the ones that actually attended, okay? So we're going to say 20 minus 15 is equal to 5. Okay, that's your difference. Now take your difference over the actual, and that's 15. So take 5 divided by 15, and you get 0.333 repeating. It's going to continue to repeat. So that actually, if you move your decimal over, is going to give you 33.3 repeating percent. Okay, that was the last question. Now, you guys try your check for understanding and make sure that you show your work on assignment number 8. Have a good day, guys.